When naming binary ionic compounds, the most important thing to know on the periodic table is the difference between a metal and a nonmetal. So we have this dividing line on the periodic table that I have outlined here in blue that separates out the metals and the nonmetals. So anything to the left of that stair step, except for hydrogen, is a metal. And anything to the right of the stair step is a nonmetal. So these are all nonmetals. Why that's important is that what we're going to name are binary, which means two, ionic, which means that one of the elements has given away electrons and the other element has taken it. So binary ionic compounds, the way we name them is based on the metal and the nonmetal. So let me give you just a few examples. So the first thing we have to figure out is what type of metal do we have. So type 1 metals, I want you to notice, so I have Na, Mg, Al. Those are type 1 metals, and the reason why they're type 1 metals is because they live in certain groups on the periodic table. So I'm going to clean up my board a little bit. And what we're going to see is type 1 metals. They live in the first two columns on the periodic table, and aluminum, zinc, and silver, and sometimes cadmium we talk about. Those are considered type 1 metals because they only have one, what we call oxidation state. So sodium is always going to be +1. It's going to lose 1 electron. If you look at the periodic table video, that might help you. Magnesium will lose 2 electrons. He's +2. Zinc, well, it doesn't seem to have a number written in there, but zinc will always lose 2 and be a +2, and silver will always lose 1 and be a +1. Aluminum will always lose 3 and be a +3. But everybody else in the gold and kind of green section, they can have multiple oxidation states. And so those are my type 2 metals. So type 1, and then all these little gold areas, so the gold through the green all the way to the stair step, except for the ones that I have outlined, are type 2. And we'll see that the type 2 require a Roman numeral. I call a middle initial. So let's take a look at how we name type 1s. So I just call it the just name it section. So if the element, first element, is a type 1 metal, you just name it. So this would be, the first name of this one would be sodium. The first name of Mg would be magnesium. But then what we do to the second one is I know that Cl is chlorine, and we change the ending to chloride. So the nonmetal, so the second element is a nonmetal in a binary ionic compound. I call it a well-balanced meal. You have something from the metal side and something from the non-metal side. So magnesium is the metal, just name it. I think of the magnesium and the metal as the man in a relationship. When they get married, they get to keep their name. But the woman usually changes their name. So chlorine is the bride, becomes chloride. Oxygen becomes oxide. So notice that what we're doing is we change the ending of the nonmetal to ide. That's actually a negative ion. They have endings of ide. So then how would we name Al2S3? Well, if you look up Al, it's aluminum. That's the metal, type 1. S3, S, and again, I don't worry about the 2's and the 3's. Just totally ignore them. Just name aluminum and then name sulfur, but I can't name sulfur because it's at the end, so it becomes sulfide. Now, what's different about type 2 is that they name the same way, except they have a middle initial. We need a Roman numeral. So copper is Cu. I'm going to leave a little space, and then I'll show you how we're going to figure out what that Roman numeral is. So we have copper something oxide. Well, the way this works, I'm going to go back to my periodic table, is that all elements have to add up to 0. So I know that I have some copper and I have some oxygen. Well, if I go over here and find oxygen, I can see that he has a charge of -2. So that element is -2. So what does copper have to be? Balance out that -2 to equal 0. Some simple math. X minus 2 equals 0. So what is x? +2. Well, that +2 is what we use for that Roman numeral. That middle initial is going to be a 2. It represents the number of electrons that are lost by that metal. It's always going to be positive, so that's a +2. So if it's a +2, the Roman numeral is 2. So then let's see if we can figure out this next one. So I know that Fe is, remember, that's iron. And then S, just like it was up top, is sulfide. But I know that iron, again, if I look back, iron is in the type 2 section. It's right here. It's right here in the middle. So I take a look. Well, Fe2 is really 2 Fe's, and S3 is 3 sulfurs. So let's just kind of think about that compound, Fe2, S3. Well, I need to do a little bit of math. So what is the charge of S? Well, it's the same charge as O. It's sitting in the -2 column. So I know that this is -2 each one. So I have 3 -2's. What is going to balance that out? So I basically have 2x. It's going to be, has to balance out that -6. So it's actually going to be +3. So each iron is +3. So how are we going to name it then? Iron what? Iron, Roman numeral, 3, sulfide. So now let's look at another way. So take a look. I look like I've named these correctly. So I have metal, and I have an ide. So these are all, again, binary, 2 elements. One's a metal and one's a non-metal, but I need to know how many of each of those I have. So now what I require is looking over again at that periodic table and looking at the charges. And so this is where we're going to use, and again, let me just very quickly clear up my page because it's kind of messy. And so we want to write compounds, binary compounds, with the correct number of each element. So I need to know how many to do. To start with this, you write down the symbols of the elements. And so let's do the first one. So I'm going to write down sodium. And sodium is not S. If we look it up on the periodic table, it's Na. And I'm going to write down chlorine. It's chloride, but I know it's really chlorine because I know I had to change that ending to IDE. And then I need to take a look at the periodic table and figure out the charges of those. So I'm actually just going to rewrite it so we can see it right here. So I know that Na is a +1 charge because it tells me right here Na is in the +1 column. And chlorine is over here. Chlorine is in the -1 column. So I'm going to put chlorine and -1. Well, the rule, again, when we kind of figured out on the Roman numerals, is that these have to add up to 0. So +1 -1 equals 0. Well, that's really simple. So what is my compound? We get rid of the charges. We balance them out. So it's just NaCl. That's all you have to do for that one. So our next one is magnesium bromide. So when we go back here, let's just take a look. Let's write down our symbols. So we have magnesium bromide. So magnesium is Mg. How do I figure out his charge? Oh, I go over here and I find he's in the second column, the +2 column. Then I go over and I find bromine. Well, bromine is Br. What is bromine's charge? He's in the same column chlorine was in, so he has a -1 charge. But now we have a problem. This does not equal 0. +2 minus 1 is a positive 1. It needs to equal 0, so it has to be electrically neutral. So how do I make that happen? Well, I know that if I can multiply bromine by 2, then I can say 2 times a -1 is a -2, plus 2, well, that's going to get me a 0. So if I rewrite my compound, then I know it's just going to be 1 Mg and 2 Brs. So Mg Br2. Well, a little trick that we can use to figure that out without having to think a whole lot, so I'm going to kind of undo it, is as long as they're not the same, we can cross them. So the 2 from Mg, not the plus, but the how many, the 2 from Mg tells bromine, I need 2 of you. And the 1 from Br tells magnesium, I need 1 of you. So we write it down, but we don't include the 1 because the symbol itself is an understood 1. So that's why it's MgBr2. So now let's look at calcium and phosphide. So calcium is Ca. If you have your periodic table handy, and you should have it already marked, let's look it up real quick. So calcium is a +2. It's in the second column. And phosphorus is in group 15, and it has a -3. I'm just going to write it in another color real quick. So then what do we have to do? That doesn't equal 0. So I need to kind of find a common denominator, or if you notice, the common denominator is going to be 6. So this 3 is going to go down here, and this 2 is going to go over here, so that they'll balance out. So 3 times 2 is 6, and 2 times a -3, it's a -6, and that equals 0. So my compound is Ca3P2. Just an easy way to look at what's going on. So then the last one I want you to notice has a Roman numeral. Well, that actually is extremely helpful, because if I look up copper, I know that copper is Cu, and the Roman numeral tells me that Cu has a +2 charge. That's what it tells me. So then all I have to do is go look up sulfur, because sulfide comes from sulfur. Well, sulfur, we look in its column, it's a -2. Well, what do we know? We don't have to do anything if it already equals 0, and it already equals 0. So I know that my compound is just going to be 1 Cu and 1 S. So that's how we write and name, remember, binary ionic, 2 elements, 1 metal, and 1's a nonmetal. That's how we name them.